Hi everybody, my name is mirzahosseini and today we are gonna do the optimization process on the steel structure by ABAQUS simulator and make this to this. Our goal in doing this is create an optimal structure system to withstand lateral and gravity loads with high ductility. I've done this process before, but we will repeat it briefly once, so let's get started. In the first step, we build our part from the part module. Each floor is considered separately so that we can apply gravity load to the deck. From the upper tab part, I choose part, create part, name part 1 is OK. Modeling space is 3D, type is deformable, shape is solid, extrusion, and approximate size is 50. I choose metric SI for the simulation and click continue. With rectangular icon, I make a square of 20 in 20 meter, and with add dimension icon, I correct my dimension. 20 is OK. Here 20 is OK, and I extrude it 5 meter. It's better to mesh our parts so using partition cell and the point and normal technique. Another time point and normal, and okay, we are done on part module. Another part is property. From the property module, we specify the elastic and the plastic properties of steel. From the upper tab, we choose material, create a material, name is steel, general density 7850, mechanical elasticity and elastic, Yang module is 209, and Poisson ratio is 0.3. Mechanical plasticity and plastic yield stress is 315, and plastic strain is 0. Second line yield stress is 385 megapascal and plastic strain is 0.1. The third line yield stress is 400 megapascal and plastic strain is 0.15. Okay, we need to define a section. From upper tab, we choose section, create section, section 1 solid homogeneous, and continue, and material from here is steel. We have to assign our section to our part, so choose assign section and pick whole part, and section is section 1. Okay, another module is assemble. We use creating a stand and choose part 1. We need to rotation part, so it's rotation icon, choose our part and pick 2 nodes on X direction, and 90-degree rotation is OK, and with translate icon, part to the 0 and 0. We have to reproduce this icon 8 times for 8 floors, so use linear pattern and reproduce it on Y direction 8 times. Okay, we are done here, and the next module is a step, and we have to choose our step for analyze. From step manager, create an step 1 static general, continue, and time period 1 second is okay, and we have to enlarge displacement. From the increment, maximum number of increment must be huge number, and the increment size initial 0.2 is okay. Minimum must be tiny number, and the maximum increment size should be more than increment size initial. 0.25 is okay, and dismiss. We are done here, and next module is interaction. We have to define interaction between floor in this module, so use constraint and tie and surface, and choose floor 1 upper surface, choose the upper surface, down, and replace again, and replace second floor, and choose bottom surface, and accept default option. Okay, I replace all. You have to down this for another floors. 7 times you have to define constraint tie. Another module is load. You have to define your lateral displacement, lateral loading, and gravity load. For boundary condition also we can use BC create boundary condition. Here we choose initial and continue, choose the bottom surface okay and caster. From lateral displacement you can choose boundary condition again, create, and here step 1 and displacement and rotation, and choose middle node of up story, and 10 centimeter displacement on X direction is suitable. For gravity load you can choose load from upper tab and create load. Pressure here, choose upper face, and distribution total force, and magnitude is 200 kilogram, and amplitude ramp is suitable. Okay, you have to do for another floors, load, create load, pressure, continue, choose upper face, distribution total force, magnitude 200 kilonewton, amplitude ramp, okay, and replace all. You can do for another story, and you can decrease or increase gravity loads. It's up to you. Okay, we're down here, and next module is mesh. We can use part, seat part, and half meter is okay, and from mesh part, and yes, we can do mesh. Your assemble. We are done here, and next module is optimization. From the optimization we use optimization task manager, create, and we select topology optimization. After topology optimization we can do shape optimization, size optimization, build optimization. for promote tension and shape of model, but first we have to do topology optimization. Continue and select whole model down, and we can freeze load region, freeze boundary condition. Is up to you to choose each one you want. Okay, another icon here is design response. We need two design response, strain energy and the volume, so let's choose them. Whole model, strain energy, and create whole model, volume, and okay. Another icon is objective function manager, so create objective function manager. The response one, strain energy. If I want to have a high ductile structure, I choose here maximize design response value, and if I want to have a very tough and a stiffness structure, I choose here minimize design value. But I want to have a high ductile structure here, so I choose maximize design response value, and okay. Another part is constraint manager. Create, and you choose response 2, and from his 0.2 that shows remain just 20% of this volume at the end of optimization process. You can increase or decrease this number, is up to you, and okay. And the last module is job. You can define optimization process manager. From here, create, name is optimization, maximum cycle you can increase or decrease, and from here you can use multiprocessor and decrease your time of analyze. Okay, after validate of the model, you can submit your model for analyze. I have done this before, and you can see the result here. As you can see here, we have a diagonal column, a steel shear wall for this stand, from gravity load and lateral loading, and you can see the result. Okay, without this you can change the variable from model, and it's up to you, and you can see different type of design modeling by ABAQUS optimization. Please comment your idea below from this post for me, and you can stay in touch with me by Gmail. I tag here. Thank you very much.